But okay, so do you guys want to see the easy way to do this? All of this. Well, not all of it, but if I can find any one of these things, I can find the rest of them. So I'm going to go back to the same picture here, the one I had. Can I copy it over? And I'm going to paste it here. Okay, so all of this can be done by an easier method if I use Gauss's law. So I'm going to erase this. And I'm going to tell you that Gauss's law said E dot dA equal Q enclosed over epsilon naught. So I've written the Gauss's law again. The big question when we look at Gauss's law is I don't have to worry about any of this. Or that, or the angle, or this distance. What I have to now worry about, or this dx, what I now have to worry about is what kind of a surface I have to define in order to figure out what my E field is at any given point. So if I have a strict, like a rod, what kind of a surface will give me the best indication of what the field is at this point? I have a choice between a box or a sphere or a cylinder. So what do you think I should use? What is the most logical explanation? So the most logical explanation is if I use a cylinder and I wrap my line charge in it. So that defines what my Gaussian surface will be. And I can draw my Gaussian surface so that on my Gaussian surface, the point I want gets included. Do you see it? Okay, now on this side, what will I have? It's a dA. How many surfaces exist on a cylinder? Which three? The top and the bottom? And the surface that goes around. And do we remember when we drew the flux? I drew it like this. So will anything be coming out of this surface? Will anything be coming out of the bottom surface? So the only field will be coming out will be through the curved surface. Agreed? So when I draw my right-hand side, may I draw them for the two circles as E dot dr r d phi plus, and then times 2, plus the curved surface, which was E r d phi and dz. We did this, right? Like last week when we were talking about cylinders. And that equals Q enclosed over epsilon naught. So since there's no E field for the circles, may I just ignore this part? What am I left with? With these limits of integrations, may I rewrite this as integration of E R d phi dz 0 to 2 pi 0 to L equals Q enclosed over epsilon naught. 2 steps. Is E a constant at the point P? Yes. Is R a constant at the point P? Yes. So can I take both of those out of the integration? E R integral over d phi 0 to 2 pi integration of dz 0 to L Q enclosed over epsilon. So what's my answer? E R 2 pi L Q enclosed over epsilon naught, or Q enclosed over 2 pi epsilon naught LR. And drum roll, what was Q enclosed over LR? So Q, this can also be written as E equals lambda over 2 pi epsilon naught times R. Look at this smiley face equation. Have you seen this before? It's the same as this smiley face equation. This smiley face equation 1 took how many steps? Like a gazillion. And smiley face 2 equation took how many steps? Like 4, 3. Yeah, Nick, you might be right. 3 steps, right? And we're there. That's the power of the Gauss Law.